All right, what we're going to start with today is kind of just remember you got things due on Friday. Most of you have that stuff done, so I appreciate that immensely. What I want to do, and again, don't forget college credit, admission to Weaver State by Friday. That's $30. Okay, I know it's like sounds like a lot, but and it is. Okay, they want to get you all set. So what I want to do is go over a few symbols that you're going to be using on your plans. And as we go through this, we're also going to talk about some code. So that makes it a little bit of a dual list here. And this is kind of, a lot of it comes out of the reading you've already been doing. I'm trying to keep the reading to a minimum for you because it's boring to read on a screen. And it's even more boring to have to buy a book. So the book for this course, there's actually two of them if you're at college. And let me show you what those are, so you can see that. One is using Revit to design a house. It's this residential design using Autodesk Revit 2021. We're not using 2021, but the book's changed. So, so that's this one for 1 and 2. And then if we're doing 3, and this is yours, Gavin, this will be designing design integration using Autodesk Revit 2021. That's a commercial process. I'm not making you buy the books. One, they have a very low resale value, very, very low. So you don't gain anything by doing it. 2, you don't have time to do the tutorials and a house and a commercial building at the same time, okay? So those will be the textbooks. They're referenced in your syllabi or disclosure, whichever way we go with that. Because this is a college course, we do syllabi, which is why I don't need to sign them, because no one does that in real life and it doesn't mean anything, okay? Okay, here we go. Floor plan symbols. So on the left, there's a lot of different symbols. We used to have to take a little plastic template and trace these out on the plan. Took hours and hours and hours. Now they're in what are called blocks or components. Blocks in AutoCAD, components in Revit. The nice thing about them in Revit, if you do something like this grand piano right here, in Revit it's 3-dimensional. It is the full piano, all 52 keys. It's crazy. And you can change the color out of whatever you want. So that's kind of cool. We still have these as 2-dimensional blocks as well. They look more like this here on the right, but they are available, and there's a lot of them. And people make a lot of money making them if they do it well. That market's diminishing because once they're made and shared, they tend to pass around a lot, and it's hard to make money doing new ones. All right. So what we're going to look at is your floor plans, and we're at the process of finishing up the 2D. Did you get that? So on your plans, now for those of you, the commercial kids, you guys you're going to have to really think about what your symbols are going to mean, because we actually have the same symbols for commercial and residential. You very well have a grand piano in a commercial space. That's not uncommon. You might use marble in a residential space. And so we want to make sure we get those down pretty well. So the reason we're doing the floor plan is to hopefully give whoever that client is an opportunity to make sure the house meets their needs. Here's where it gets tricky. Most owners have no way of thinking 3-dimensional from looking at a 2-dimensional image. They have a hard time understanding the space involved. And they tend to keep wanting to make things bigger. And that's where you really have to be kind of their advocate and their mentor and guide them through the process. 3D helps that a lot because we can actually do a walkthrough. We can send a little camera through the space and they can get a feel for what that's going to look like. And that's always helpful for lots of reasons. And let's kind of see if we can get through this a little bit here. All right, next thing we want to look at over here then. It's a quick way to communicate to the contractor what you want. Now, each symbol means something different. So on a lot of your plans, we talked about the wall that has a little dotted line in it for an archway or an opening in the wall. Contractors know that, but they don't know everything about it. So we might have to do what's called an interior elevation to know if it's a flat, squared off opening, if it's rounded, if it's elliptical, if it's an onion shape. There's a lot of different things to do there. And we're hopefully to reduce errors. Now, BIM, which is our other topic of the day, fixes a lot of those errors, because one of the things that happens when we're doing house plans just two-dimensionally is we'd have to take the sheets and overlap them and trace off from plan to plan. And we would do that and be really good for the whole set, made sense. But when we got to the subcontractors, the people doing the plumbing got one sheet, the electricians got a different sheet, the HVAC guys got a different sheet, and we're all there at different times usually, because if they're there together, they fight. Those three subs fight a lot. They want the same area for their stuff. And they would cut each other's stuff. They'd put pipe where there's supposed to be water, and water where there's supposed to be wiring, and wiring where there's supposed to be gas lines. It's never good. So we have to coordinate that. And that's what the general contractor generally does, is keeps everybody happy. But when we do a BIM model, they can see exactly where everything goes, because we can get down to the nearest 16th of an inch. And so we can get things really tight, and so they fit in there just the way they're supposed to, which is kind of fun. So some of you may think, well, I'm going to be going to architecture, and that's what I'm going to do my whole life. And then you get a call from someone like Young Electric or Cash Valley Electric, and they say, hey, we need someone to do Revit to just plan out where electrical wiring goes. And you find that that's really what you like to do, because you're one of those people that like to untangle knots and fix. All right, so the first thing we'll look up is kind of materials. Now, typically on the plans as we go, we're going to give the name of the room, and then they give underneath the material that goes on it. So maybe carpet or vinyl or tile. We used to draw these rocks by hand. There's now symbology for those. And so we don't have to draw every rock, which is kind of nice. It's also kind of sad. One of the things I really enjoyed is after you've been working a really bad Monday and everybody's gone home and the office is locked up for the night, you could spend your next few hours drawing rock, and it's very relaxing. It's a good way to unwind for the day, and I kind of missed that a little bit. So this is slate. If we were doing something like the tile downstairs, it would be very much like what's here in the shower. So this is a shower tiling system. A couple things about here. So we have a door swing. So this would be to get some terminology in as you go, especially for those doing the construction terms. This door is hinged on the left side. So this is a right-hand door, because your right hand's going to grab the knob, which is here. Okay, as it go into space. This tile here in the shower, we have these cross lines going. What do you think that represents? Slope. Yes. You'd want your shower to drain. You don't want it to just pour out over the bathroom floor, because that'd be bad. The circle in the middle is your floor drain. So we want to have it slope down. Do you do that with the finish, the subfloor, the wood, or do you do that with the tile? Tile. So they use grout, and they have to level that. Some tile layers are better at that than others. And as the designer on charge, that's one of your things is to go through and actually, when I go and do it, I take a little 6-inch level, not a very big one, and I make sure that floor slopes the way it's supposed to. Because the one thing you do not want to have is a client call you and say their 13-year-old son just took a 4-hour shower and their whole house is flooded. Okay, names, and all this comes as we go through. So this being your checklist as we get going, you'll get checklists to make sure a sheet or a page is completely done. So you know you're ready to go. The ideal is to have your plans all ready by the end of the year, that all you need is to have an engineer review them, and then you can build your house. Well, that's kind of a cool thing. All right, these are things that often get forgotten, okay? So this PowerPoint I will put in to your course later, but because it's not there right now, but I'm gonna add this into it. One is your garage, okay? Your garage is gonna have a 4-inch concrete slab that's gonna slope 1/8 of an inch from the back wall toward the door. Why are we doing that? Don't flood your house. Yep, all that snow we're gonna get this year, by the way, it is gonna be a heavy snow year according to Farmer's Almanac. So 2020 is not done with us yet. It's just gonna keep going. Yay. It is possible to actually put a hose bib, a faucet, in your garage. I have clients that do large custom homes that have to wash their car religiously. And so they have hot water running in their garage to wash the cars. When you get in these custom homes, there's a lot of crazy things that happen. That means you've really got to make sure. I change the slope to 1/4 inch then if they're going to do water inside the garage, just because people do stupid things. They forget to turn it off, so things like that. It's somewhere in your house, you have to have access to the attic. This is also the case on commercial buildings, but usually what we do is it's part of like a stairwell or an elevator shaft. But in residential, we have to figure out where to put it so it's not ugly. So it might be at the end of a hallway. It might be inside of a walk-in closet. That's a really common place to put them because they're out of sight, out of mind. These are primarily just so you can add more insulation as the years go on, because usually when we do an attic, most people have chosen to go with what's called blown-in insulation. So it's ground up newspaper, and it's treated, so it's got insecticide in it, it's got flame retardant in it, they blow it in, it gives you lots of fluffiness, and it helps to capture air. But over time, that degrades and it settles, and so it's not as thick. And so you just add more in. I'm not a fan of that insulation for 2 reasons. One, we don't have any newspapers to use anymore to recycle because they've all gone out of business, which is across the nation overall. We used to have tons and tons and tons of newspaper to recycle. That's not the case. Most newspapers have gone digital. 2, when you have that much fluffy stuff, things that like to make nests love it. Well, so bats, mice, rats, it starts to become like a draw for them. And even though it's got pesticide in it, they don't really eat it. They just use it for nesting. And so we're not really doing any good there. So I'm not a fan of that. I'm more of a fan of fiberglass. It doesn't settle, it doesn't compact, or the blown-in styrene. So what that is, it's like the foam around your styrofoam food containers. You blow that in. Nothing eats that because everybody knows it's out of oil, and so it doesn't draw pests, but it's very, very, very good insulator. That's why we use it in the food industry, and I like that a lot. We'll look at some videos on how that's done a little later. This access hatch needs to be shown. It has to be a minimum of 22 inches by 30 inches. Now that size is the minimum size needed for a fireman to crawl through. Okay, now let's think about what's going to happen here. The roof's on fire. Is the fireman then go up in the house and then into the roof? No, they're going to come from the top down. Okay, almost always. But once they do need to have that access in the event that they do decide to go 2 ways at it. We want to make it easy. We want to have as little damage as we can. So this is mainly for fireman access, even though they're most likely to tear your roof apart first to get to the fire. But we still provide it. Okay, and this is one thing that gets a lot of homes not approved for permit because they forget this. This is a fiberglass shower. So it has to have waterproof gypsum board. Anybody know how you make waterproof gypsum board? Or what is gypsum board made out of? Let's talk about that first. Anybody heard of plaster Paris? It's the same stuff. It's just gypsum, and when it gets wet, it dissolves and then it hardens back into rock, which is not good. So if the fireman's in there blowing down the fire, your wall is literally melting away, and then it's going to pull up into a big puddle of rock. When we do waterproof, it's made out of concrete. So it's, you can call it green board or cement board. So it's a little tougher, much heavier, but it can withstand the water of a shower or a tub surround or a sauna or a jacuzzi area. Anywhere you have a lot of water, indoor pools, you need to use this waterproof gypsum board. Your laundry room needs a drain. Okay, this one gets left off a lot. Usually it's going to be right up next to the washer itself, because we now have to, under code, the wash and dryer have to sit in basically a pan that if they do leak, it captures that before it hits the floor, and the drain will be there. But we've had a lot of washing machines over the years that have overflowed. We get them sometimes, and we make fun of it in the movies where the washing machine walks across the floor and chases people down. So that means that we've got a lot to be aware of in that situation, and we want to keep that water contained. Okay. This over here is a hose bib. It's the outside water faucet. You have to have 2 of these. Then typically there's one in the front and one in the back. The minimum is 2. Why are we required to put a hose bib? Why do we need water outside? So you can water your yard. Usually we do sprinkler systems, but if you get wet east of the Mississippi, there are no lawn sprinklers. They don't water their lawns like we do. So they still have to have those hose bibs, because they may be used for washing your car. They may have animals that need to be watered. They may have flower beds, things along those lines. So we do have to have water. Here's the downside. This water is culinary. That means it's the same water that's in your kitchen that you can drink. Like we talked a little bit about this a little bit last time, or a week or 10 ago. Utah now allows you to use gray water that you can use in these. That's the water from your tub, your shower, your sink, your dishwasher, your washing machine. Not anywhere around a water closet, but all the other water sources can be collected and used to water your yard. And that's a lot cheaper, because now you're not buying double water. You're able to recycle that water. Okay. So coming over those. Okay. This is a window well. It's a very fancy window well. And we're going to talk about how this works a lot. There's 2 different styles. This is more of a corrugated style. This would be a precast concrete style. They need to be 6 inches, well, about a foot wider than your window is, and they need to come out from the window 3 feet. Now, if you're down at a basement level, they also have to have a ladder in there, and the top of it has to be covered with a grate or a lid, but the lid has to be able to be opened by a 5-year-old on the ladder to get out. So most people have chosen to change their design and not go that deep. There are other ways to do this. When we get working on your foundations, we'll talk about these a little bit more. But window wells are required. You can make them very decorative. You can avoid both of these by doing what's called a terrace and just slope your soil. So you can have grass or flowers. One of my favorite projects, the guy planted berries, like strawberries and blueberries. And so they could just, they're down their family room, they can open a window, pick berries, and it was kind of nice. So we want to make sure we have that addressed. We look at our wall symbols. We have to be exact, very, very exact with these. So we're not, when we start, we don't include the sheetrock. The studs are always vertical, and we can see them kind of back in here, but not very well. We have various types, everywhere from a 2x4 to 2x10. They're in usually 2-inch increments, 2.4, 2.6, 2.8, 2.10, 2.12. Then we get into beams. Now these beams, they start out at 4x4. You can go up to 12x12 with a wood beam. And you'll see those in ski lodges a lot, or cabins. We'll use those larger. They don't have to be square. They can be rounded as well. Okay. Again, we're going to treat a 2x4 like it's 1.5 by 3.5, 1.5 by 5.5, and so forth. Okay. Now, if we're using a 2x6, we do not have to follow the 16-inch on center framing. The 2x4 does, because they're smaller member. But when you're using a 2x6 stud wall, you can frame those at 24 inches on center. So you're using less of them, which is good because the 2x6 costs more than the 2x4. So you can do a little bit of cost savings there, and you still have the same strength in the wall. You do have to let your clients make sure they're aware of that, because if they're hanging things on the wall, where they're used to putting nails won't work. They're used to measuring 16 inches to find where the nail goes. It won't be there, okay? Now, the length of your studs from end to end is 92 5/8 of an inch. That's how long they are. So what is that in feet? You divide 92 by 12, what do you get? What do you get? 7 foot even? It shouldn't be. That's a very short ceiling. What is it? Maybe get the math. What was it? 7'6". Okay. There's a problem with that. Okay. That means that all of your ceilings are just 8 feet. By the time you get the double, when we frame them up, there's a board on the bottom, 2 on the top. We'll talk about that in a minute. That means your highest ceiling is 8 feet. Do any of you have ceilings that are higher than 8 feet in your home? Yeah. How high are your ceilings? Do you know?
We have 10 feet ceilings, but then we also have like one area where it goes up to like 11 feet.
Okay. Yeah. And so we like that. We like that different heights. So we have to be able to buy different lengths of studs, and you can get them in 10-foot lengths, 12 foot, 14 foot, because you just get them before they cut them. So don't let that be a restriction. I personally like an 8-foot ceiling in the bedrooms, but I like it higher in the public rooms. So I do a lot of mixing as well. Okay, so if we're doing a wall, this is your plan. This is where you come out. The dark blue is kind of where you guys are at. What we want to look at is, we're not going to show the vertical studs in a floor plan. These would be called wall details. And because of the standard nature of framing a wall, these are obsolete now. We don't have to show these because contractors kind of have this part down now. But what we may want to do is show what our material is like here with the brick. So this is a 4-inch brick masonry unit. We have a 1-inch airspace. We have a 1/2-inch sheathing. We're going up to a 3/4-inch sheathing here because we have higher wind loads in Utah. We're also a higher seismic zone, so we want a little more strength in our building. We have our 2x4 stud, or 2x6 now is what we're using, and then the 1/2-inch. So this kind of tells you the makeup of your wall, and that's going to be really important as we get going here today, is what it's made out of. Here's this 2x6 over here. Now, if you look on the plan, it's pretty straightforward, right? Doesn't seem too crazy. And yes, there are opinions on what you show, okay? On how you draw those, and that's okay. Exterior walls, interior partitions. So the stuff we did first, I had you guys do all of the interior partition walls first. What does the word partition mean? Separation, yeah. That's how we separate our rooms. Okay. So what we're going to look at then here is we've got these all set. And so there are partitions. The exterior are almost always, all exterior walls are bearing. They take care of the weight of the building. And so that's really, really critical, okay? So we want to make sure that they're really drawn carefully. And like right here, you can't really see on the PowerPoint that well, there's a little jog in the wall. You want to avoid those as much as you possibly can, okay? They're a weak point on the wall. In this case, it's coming in off of the outside, so I'm not really sure what's going on here, garage here. You want to avoid that, okay? You want your walls to not have those little jogs to them, okay? Okay, now, again, we talked about the space in the walls already. Interior walls will always be 16 inches on center. Your plumbing wall, this is the wall that's directly behind your water closet. It's the only wall this has to happen to. that has to be a 5.5 inch stud, 2x6 stud. Okay, now if you didn't make it that way right now, we'll do so when we get into the BIM program so that it's correct. Okay. Hallways, again, this is obsolete. It's 38 is not correct either. 36 is the minimum. 3 foot is our minimum. If we're doing a 2'6" door, that's why we need a little larger. So a 2'6" door, we then make it a little bit wider to accommodate the framing for that. Okay, and so we have to really be careful how we frame things in. We'll talk about that more as we put up our plans. Bedroom closets, this has a little deep. This is without the gypsum board. Okay, I had to draw with the gypsum board. So if you add or subtract an inch off of this, you're at 24 inches. Now the width, 49 inches. If we add an inch to that, that's 50 inches. Does 12 divide into 50? It doesn't. So 12 times 4 is 48. So we're looking at a 4 foot wide closet. I have not seen a 4 foot wide closet built in the last 30 years. One, they're just awkward to get anything in. They're just not big enough. So most of the closets I see have a standard 4 foot wide door and then whatever excess they want to put in there. So you want to kind of look at that with the new styles just a little bit. Base cabinets, 2 foot deep for your base cabinet. We use that for a lot of your rulers that you're using. Upper cabinets are 12 inches deep. Okay. All right, now when we look at our wall partitions, we'll shade them. Now this is an AutoCAD file here. It's got a hatch pattern in there to make it stand out. A lot of that will depend on what your company's standards are. So for those of you that are the commercial students, the Architecture 3, you're going to have to show which walls you're demolishing in your remodels. And the wall that you would demolish will be changed to a hidden line. So there'll be little dashed lines on there. Okay. Now, what that's an entail then is that you've got to make sure you have walls that are separated. So if I'm going to take a part of a wall out, you have to change some of those wall connectors. You have to draw partial walls and add walls to it. So there's a little work on that. Fortunately for you guys, Revit does a demolition tool. It's a big old hammer. You hit the wall, it turns to a hidden line. It's kind of fun. I'll help you with those as you do your demolition plans, because you're not going to want to keep the configurations you currently have. So if you're doing one of the office complexes, most of those offices are very, very small. And now that we've got people working at home, we want bigger communal space and less office space. Okay. Hatch commands are in AutoCAD. It's easy to create. We don't need to worry about them so much in Revit. Revit shows all the components of the wall. So when we do our Revit wall, it says show the stud, it says show the gypsum board, it says show the sheathing, it says show the brick or the stone or stucco. All that's going to be shown. So we don't want to add more detail. It's overwhelming to do that. So Revit's a little different animal. We don't have to worry about showing this much detail. Okay, a little bit more on code. This is going to be important for you. This is kind of crazy. This is a deck. If it's more than 30 inches, and the key is more than 30. 30 inches and less, a guardrail is not required. But once you get a 1/60 of an inch above that 30 inches, a guardrail is required. So what a lot of times will happen is they'll put a flower bed here, put in some extra soil so they don't have to put the railing on. Try not to let that happen on your projects. Don't let people cheat the code. The guardrail is to keep people from falling. Now, most people that fall a foot and 2.5 feet, you're not going to break anything, right? But if you're a child, you might break a neck falling that low because kids are kind of bouncy. And so we want to be aware of that. Don't let people cheat the code. If they build it wrong, then have them fix it. Kind of watch for that. When you put these vertical slats in residentially, you have to make sure that there's not a gap between each one that's greater than 4 inches. So the test on that is a racquetball. If a racquetball slides through, it's too wide. That's usually what the inspector carries around as a rubber racquetball. And if you can push it through, you've got to justify why you did that and show how you're still in compliance with the building code. If you're doing commercial, the slats opened up to six inches. So they get a little more open because people are supposed to watch their kids, not supposed to be responsible for the public. What happens? Does anybody stick your head somewhere you shouldn't have? Yeah, lots of times, right? Most of us have done that. Why can't we get our head back out? It goes in really well. Why can't we come back out? Chins? It's more this. Your ears are like barbs, and when you pull them out, they hold you in place. And because there's so many nerves in your ear, it hurts more than what it really would. We feel it more. And so that makes it kind of tricky on there, okay? We don't want kids getting their head stuck in there because it's traumatic, at least for the moment. The other thing I want to look at there with guardrails, this 30-inch rule, it can be your best friend. Again, there are ways to manipulate all the code. There's always an option. There's always a loophole, if you will. But you want to think about what they're for. The building codes are to keep people alive. That's the whole purpose behind them. Now, when we get over to your stairs, as we do your stairs, you're going to have a handrail. If your stairway is only 3 feet wide, you need one. You don't need one on each side, just need one. Once your stairway gets to 4 feet wide, then you need two, one on each side. If you go to 6 feet or more, you need one on each side and in the middle. And that will apply more to the Architecture 3 commercial projects. If you've got a 6 foot wide stair, you need 3 handrails on it. And that's it's kind of cool, but it kind of gets in the way a little bit. So just kind of be aware of that. We also have a height requirement. From the stair to the bottom of the railing cannot be more than 3'2", okay? And it can't be less than 2'10". So 2'10" is where most handrails are, because we've still got a majority of the population that's still at average height. This class is an anomaly because the majority of you in here are taller than the American standard, the American average, which is kind of a nicety in a way. So if you've got tall people, you want to go to the taller side because your arms are still proportional to your body and they still hang at the same point. The reason for that distance is when you let your hand hang limp, that's where your hand is that 2'10" from the floor. And so it makes it easy to hold on to them. The other thing we're looking at is the size of the handrail. It needs to be at least 1.5 inches away from the wall and cannot be more than 1.5 inches in diameter. And that's, again, if you let your hand go limp, that's the size that's made with your index finger and your thumb, is 1.5 inches. So if you get arthritis or you get palsy or whatever old age does to people, you can still hold on to that. Now, there are ways you can manipulate this as well. You could take and have a circular portion on top and then extend that down to rectangular as long as you can get a hold of a handrail. And we'll look at some of those styles when we get to designing your handrails, what you want to do with those, okay? But you do want to keep track of where people are grabbing. The same holds true of doorknobs. Doorknobs are only 1.5 inches in diameter, or they're a latch. Thanks, man. So if they're latch, why do we put the latch on them? You don't need to hold them to them all. You can use an elbow, you can use a stub, you can use a foot, you can use a crutch. Makes it really easy to open and close those doors, okay? And just keep in mind these little guys, don't let them fall through, okay? People do silly things. Okay, we're gonna skip all the talk now. Door symbols, this one we talked about when you're doing your plan. That's why we haven't put doors in yet. From the corner to the hinge side of your door, 4 inches, okay? You can squeeze it into 3, but then you're expecting your contractor to do all the other measurements right, and they probably won't. So if you do 4, that means if they mess up, you're still okay. Everything still fits, okay? And that's kind of important. Okay, so this you might want to make a note of. Utility doors. These are doors like into your furnace, your laundry room, 2'8". We kind of talked about that. Bathroom doors can go down to 2'4" wide. And we talked about that not being a good idea because if you have to remodel, you got to tear the door completely out. Bedrooms 2'6". So I try and stay 2'8" with most of my doors. It's a little bit more money, but because they're a little bit more money, they're built a little better because they're not mass produced as much. And so you get a little bit better quality out of them. If you have a closet door like into a linen closet or a medicine closet, something like that, or game closet, 2 foot's plenty. If you're not going to walk through the door, go down. Now, what do you notice about all these sizes? What's the common thing? They're all over 2 feet in this case. You can go smaller. You can get 1 foot doors. They're on your cabinets. But doors always go in 2-inch increments. So if you start at 1 foot, then you got 1'2", 1'4", 1'6", 1'8", 1'10", 2 foot. Doors are always in even increments of 2. Okay, and then you can have whatever size you want. If you don't see an catalog of the door you want, they can all be custom made. It's not like really big rocket science to make a door. They're not that complicated of a thing. Same holds true now. Commercial people, you don't get any choices. Every door in a commercial building is 3 feet. Every door. They're all 3 feet. That's what you get. Any size, shape, or situation can work. Primarily wheelchairs. So if you're in a wheelchair and you're hand pumping the wheels, if it's anything less than 3 feet, you won't make it through. You'll lose a knuckle or something. And so keep that in mind. Again, we talked about having at least one exterior door 3 feet. That could be the door from your garage into your house if you choose, but you make sure it's labeled well, okay? All residential doors are 6 foot 8 inches tall. They're all 6 foot 8 inches. That way when you get to the top of the trim, they're at 7 feet. That way they line up with your windows. Commercial doors, Architecture 3 guys, every one of your doors is 7 foot tall. They're taller. So when you get to the top of the trim, you're about 7'4" in some cases, depending on the trim they use. But your doors change. Residential, 6 foot 8. Commercial, 7 feet. Okay, then we get a little bit of fun, okay? The reason for that 4 inches from the wall is this trim work. We can get really elaborate trim. If you're going to go with a colonial style home like this one, you may have trim that's up to 8 inches wide, especially doing the hand carved stuff. It gets very, very large. And then it doesn't fit in the corner very well. It looks like it was a mistake. So you want to put, if you're going to do a lot of woodworking in your building, plan for it. If you're doing a law office, they hate these metal doors we have here. If you go into a law office, they'll cover it with wood every time because wood makes you look a little more prestigious, a little more wealthy, a little better at what you're doing. If you go into a law office and they've got cheap stuff, they're probably not a good lawyer, right? They're probably just chasing the ambulance type thing. So you want to look for that and how that works. Okay, so hinge, left-hand door, hinge, right-hand door. Okay, kind of a weird, so as you go through, okay? So if you're going through, look at what hand you'll grab the latch with. Okay, you gotta look at which hand you're watching there. Okay. Okay, so a lot of times if you've got a door at the end of the hallway, that will determine what size hallway you end up with. Okay, let's talk about door symbols themselves. A pocket door. And a pocket door is, you'll see them off the restrooms, kitchens. They don't take as much space. The situation is you have to be aware that they're there. If you put a picture on the wall where the pocket is, and you use a large nail, you may nail this door open or closed. And that would be bad, okay? These are bifold doors. Each angle here is 1/4 of the distance of the opening. So if this is a 4-foot opening, then this is 1 foot, 1 foot, 1 foot, 1 foot. Okay, so when it closes, it fills up. These are the ones we talked about, these bypass doors. Not so friendly, they're awkward. Okay, or you can put in a French type door, okay, which is where we just have the double doors on there. Okay, so kind of fun. And French doors you'll see more in like dens, you'll see them there, maybe a parlor, sometimes in a craft room or a family room. Usually from a master bedroom out onto a porch or balcony. Okay. Then we have weird doors. So this door right here is a Dutch door. Mainly it's where there's a little, usually a shelf involved where you can put your pie to cool off before you eat it. The door is split in half, so the top can open or the bottom can open. The reason they're Dutch doors is that's where they were invented, but it's primarily because of how they lived there traditionally. The bottom of the house was the barn, the top of the house is the living area. Because when they get snow, it's 8 feet deep there, or used to be anyway. And so what they could do is you could open the bottom, the animals could come in, the top steps closed, or you can close it and open the top to get airflow through there. But you see them mainly in libraries now. They're not too common in homes. We used to see them in the kitchen, the doorway in and out of the kitchen a lot. They're not quite as popular as used to be. Then we have accordion doors. They fold up. These suckers are expensive to maintain. They tend to tear if they have kids running through them, so that can be kind of rough. This is a sliding glass door. You might see those in your family rooms and out your patios. And then we have good old, what are they called? Saloon doors. Yes, good old saloon doors. These are kind of popular in the early 80s, late 70s in kitchens. They've kind of gone out of style because kids get whacked in the head with them a lot, and they swing both ways, which makes it even worse. You get hit twice with the same door. So, but you're welcome to use those if that's in your style. We don't see too many saloon doors anymore. And atrium doors. This is a type of French door. This panel here is the one that moves. This one's fixed. It's just a window. Now, when you're looking at these big doors, these sliding glass doors and big French doors like this, they're really not classified as a door. They're really a window. They're just a very large window. And what we have to do with the glass in these, the glass has to be tempered like the glass in your windshield of your car. So if it breaks, it's little teeny tiny squares, and you're not going to get like capitated. That'd be bad. So if they're much more expensive to do it that way. Okay. Showers. Yay, showers. I love showers. Okay. You can have a completely glass shower if you want. I don't know why. It seems creepy to me. I'm not a fan of the full glass. Hotels tend to like these. I don't know why. There are a lot more cleaning involved. But again, a glass shower or glass shower door has to be tempered glass. You do not want to get deep cuts in a shower, especially if there's hot water going. What happens with hot water and blood? You bleed out really, really fast. Okay. So if you've got a hot water and you're bleeding, you'll bleed out. And so just something to keep in mind there. You'll see these sliding glass doors kind of often. If you're going to do this, maybe go with them frosted, so they're not translucent, they're just transparent. People like them because it gets more light in there, but I personally don't like cleaning them because they get water spots really easy. Okay. Your shower door can be as small as 2 foot, but it still has to be 6 inches. This is another way of showing size. So it's 2 foot, 0 inches wide, 6 foot, 8 inches tall. And this is a way to label your door sizes without doing a lot of extra work. Okay, on there, which is tricky. Again, all the elements are here. And that, now this one has 2 shower heads on this one. That's pretty common in master suites to do that, to put two or more showers. I just did a bathroom just before COVID where it had 2 shower heads, a steam bank, and a waterfall shower in the middle. You would get waterlogged in there. It was a ton of water. Thank goodness. One of the good things that President Trump has done is he's taken off the pipe regulation on showers. It used to be that every pipe going to a shower had to be less than 3/4 of an inch, which means you had no water pressure to do more than 2 shower heads. That was undone, so now you can have a pretty decent shower again. kind of cool. Garage doors, we haven't talked about those. They're shown in their open position on the floor plan. So we don't put lights or hanging things where the door is going to be. Your lights and your garage door opener would go above the plan here. Lots and lots and lots and lots of different styles of garage doors. Okay. When we get to that point, we'll talk about it. Your single car garage door is 9 foot by 9 foot. So if you got big mirrors, it's a tight fit. Okay. And we'll talk more about these as we get to that point. So doors 8 feet wide to 18 foot wide. You can actually get a 22 foot wide door, but they tend to be replaced pretty often. They tend to get warped. 7 foot to 10 foot. Now, if you got a truck, a 7 foot garage door is not going to do any good. Okay, so usually you'll see garage doors start at 8 foot and go up. You can get them taller than 10 feet. If you've got an RV and you're doing RV garage, you can get a 16 foot door, 22 foot door. So really, just because they're suggested sizes, if you go to the manufacturer's page, you can get pretty much what you want. Okay, almost done. Windows, I think I'm going to leave windows off for now. Again, same thing, width, feet and inches height as we get there. Because we're kind of going, PowerPoints are so boring, right? Okay, so we're going to pick up window symbols next. We'll kind of close this out. You guys get some time to get the majority of your walls drawn? Cool. All right, anybody need a break real quick? Yes, sir. You need help. Okay. I'm going to do a quick break. Let me check in with the online people. Nick and Gavin, do you guys have any questions real quick?
Nope, all good.
Okay, good to know. Okay, so we're going to do a quick break. I'm going to switch gears. If you need water, 5th floor, or you can use the bathroom if you don't mind, the sinks. Let's be back here in by quarter after, so 12:15 if you're going to take a break. I'm going to go help you real quick, and then we're going to do something completely different. So you want to be back on time. Okay, so when you get into the Google templates, you're going to right-click and download GTI Architecture 24 by 36. That's a D-size sheet of paper. We'll talk about paper sizes a little bit later, but you need to download that. Okay. Yay, team. All righty. This is the fun stuff. And I don't know if you guys at home have Revit downloaded yet. Again, if you're downloading Revit at home, I need you to send me a email that you need the Autodesk letter to download it. I have to do one individually for you. The one that I put in the announcements that was to cover everybody, they rejected. So I've got to make it individual for each of you. Okay, so if you're doing that, just send me an email so I can reply right back to that email with your letter. Okay, and that's the easiest way to do that. Fair enough? Okay, so get that downloaded. Now, the fun part. And I'm going to close this. And we'll talk about why there's so many tabs here in just a second. Because there's R, big blue R, Revit 2020. Okay. Now, it's actually the version you have right now is Revit 2020.1. They're on 2020.10. Right now, they're on version 10 of 2020. There's an update literally every 3 months when they put a software out, and they update constantly, which is good, but it gets annoying because you never have the exact right version. It's just one of those annoying things. So I want you all to get to where you have this screen. And I am recording this. If you get lost, I'll post it so you can watch it a little bit later and get that. Okay. Okay, now, we good? Still loading? Yeah, don't get too lost. I'll get you in that because it'll take a while. It's a large program. How many of you used Revit before? Okay, that side of the room, they're all good. All right, well, maybe I'll teach you something new. I don't know. Maybe you can teach me something new. That'd be cool. Okay. How many are loading now? We good? Sweet. Okay, here we go. When you open up Revit, it gives you your starting. It will show you your last projects you were in once you get going, the models you've been working on as you work on them. Usually, and it'll show you the name of the file up here at the top. Then down below, these are areas you can customize for Revit. So Revit has things like families. Families are things that are already pre-grouped. So you might have a family of tables, a family of windows, a family of doors, a family of different brick. So anything that's related is a family, makes kind of sense. Within that family is made up of components. So a Dutch door is one component of the door family, okay? Then you can custom build families. So if you find something you like, you can 3D build it. Now, that's a little tricky for architecture students because 3D modeling of things like this is done in the mechanical engineering side of things. So that's why it's a good idea to take the technical design courses and get 3D modeling with BIM, because the best architects in the world design their own stuff. And if that's what you want to be, then you need as many skill sets as you can get. Anybody plan on going to the U of U architecture program at this point? A bunch of you, okay. One of the classes that I think they still offer, but they offered when I was there, was Scandinavian furniture. And you had to build a unique and original piece of furniture based off Scandinavian design. Sounds easier than what it was, okay? But that's a you still do furniture design in architecture. It's one of those things. We have structural families like framing. In this case, it's showing a roof truss, which is kind of fun. They're a little complicated, but the nice thing is we can make them into rooms as well. There's an attic truss that lets us make a room out of that attic. And then there's system families like HVAC, electrical, plumbing, conveying systems if we're doing a factory, might be a people mover if you're doing an airport. Okay, so we have all those kind of things happening here. Okay, then over here we have open an existing file, start a new file, open an existing family, or start a new family. Don't get those mixed up. If you plan to work on your house and you open up a family, it's gonna be really, really hard. It's gonna be really hard. It's gonna be like doing AutoCAD blindfolded. It feels like that. It's really hard. Okay, so we're gonna do a new project. So go ahead and click on new. Now, this little box comes up and it has, Revit has some pre-built templates, but they're basically empty, meaning there's not much to work with in them. And that makes them a little frustrating because that means every project starts from scratch. And when we work with templates, the idea of a template is we have everything ready to go so we can just go. We don't have to keep looking for things. The research has already been done. Most offices will have a standard template that they use that has everything that's common to their style of architecture. So if we look at like FFKR, they're real big firm here in Utah. They're based in Utah. They're international, and their main emphasis is educational systems. They do colleges, universities. They do big type things like that. They were the architects for UVU, if you've seen that campus. They've done a lot on UVU's campus. So they do really large systems. They have a very large template file, and it's pretty impressive. Their template file is approaching 0.5 terabyte now. So it's not one you can share. It sits on their server, and that's where it's at. So template files become bigger than your working file. When you're done with your working file, you want to purge out the stuff you're not using. And you do that at the end, so your files are easy to store. Can you imagine storing 0.5 terabyte for every project? That'd be an awful lot of space, and no one really wants to pay for that. Okay, now, so we're gonna hit on this template. If you look at the templates available, you've got none. You've got a construction, architectural, structural, and mechanical. Now, mechanical is an aspect of engineering that works with anything that moves. So this is air, water, seismic, that soil. That's all the mechanical area. Structural is things that aren't going to move. That's your concrete, your steel, your brick walls, things that are the holding weight and keep the building together. Construction template is to show how things go together. And it's just made by contractors to make changes to the architecture. So an architect comes with a big old design, he says, make this, and the contractor goes, I don't know how to make that. So they come up with an idea, and they model it out, and they get the approval of the architect, or they just do it, and then the architect doesn't know how they did it. That's more often the case. But what I want you to do is to go browse, and you then go to where you stored your template. So what's going to happen is it's going to come up with this library. Okay. Now yours is not be this long. Yours will be a little shorter. It'll have all those templates we just talked about. I need you to also open your File Explorer. And it's going to be this one, the one that's on your downloads. So if you need to find the downloads, because that's where the template went that we just downloaded out of Google Drive. When you download out of Google Drive, it's going to automatically go to the downloads folder. Okay, it's just where it's going to go. And I've downloaded a lot. And you need to find your GTI architecture 24 by 36 template file. Okay, good. Click on that. You're not going to open it here. You're going to click on it, drag it over, and add it to your library. Just bring it over and drop it. Just drag and drop. So, and that's how you're going to add, because these libraries are on the server that you don't have access to, so we have to backdoor everything. That actually works better this way anyway. So you just take it from the downloads, drag and drop, and that sits right there. Okay. Once it's in there, hit open. And it should be listed now as a template file. Now, we're not making a new project template, so we're going to make a new project. If you want to, yes, sir. Uh-oh. Uh-oh. Oh, no, you don't. Yep, it's a little complicated, but that's what happens when you do file sharing. So, yay, right? Now, if you want to work on this over the weekend, you need to save your file when you're done to your Google Drives so you can download the whole file at home, or wait till Tuesday. Okay, so hit OK. Yay, things are changing now. And I'm not sure where you're going to open up, but I need you to go up down here in the bottom is your project browser. So it's a program within a program of programs. Okay. Find where it says first floor and click on that. Should look like this. Okay. So first floor, under floor plans, first floor. And then see me next week. Okay. All right, so many things. All right, we all good now? We there? Feel better? It's always good to get the right file. All right. This is our main floor area, okay? Now, Revit is very, very much like AutoCAD, okay? Except the windows look a little different. So if I'm looking across the top here, I have to decide what I'm going to draw. So instead of drawing lines, I'm going to draw walls. Okay, so if you were to click on the wall icon here in the Home tab in Architecture, then things change. So once you pick an archetype or a type that you're going to do, then you get the same icons you've been using. So this is move, there's offset, there's mirror, there's your fillet, okay, there's your trim, there's extend and trim right there. So all the same things that you've learned already still exist, which makes it really nice, okay? Now, we're not going to do anything yet. We're going to get your plan in here, and then we'll go back and play, because I want to make sure you got your plans in here ready to go. Okay, now as we look across here, you've got architecture, you can do doors and windows. Components are anything other than these. So a component could be a table, it could be an iPad, it could be a toaster, it could be a beam, it could be a piece of rock, a tree. Those are all different components. And as we work in this, we'll get more familiar with those. We have special columns. The columns has a down arrow on it. There are structural columns and there are decorative columns. You have to, and they work in different parts of the drawing. So a structural column only shows on structural drawings. The architectural column only shows on aesthetic drawings, or the drawings that look pretty. That means you've got to make sure they coordinate and line up exactly because they overlap each other in the same space. We have roofs, and we're going to play with roofs here in a little bit. Ceilings, floors. Curtain systems are more for the commercial side of things. It's like putting glass on the outside of a building so it shines and gets really hot. Like out there by Health Center Theater. They've got that big old glass wall there off the freeway that in the afternoon kills everybody because it's a big old laser beam heating the freeway up 40 degrees higher. Crazy thing. We can do ramps and stairs and railings. All that set up in here. And we'll do some modifying. But here's what I want you to do. I want you to go to the Insert tab. And we're going to bring in your AutoCAD drawings. So commercial, architecture, residential, architecture, we're all doing the same thing right here. Okay, now as we get ready to do this, I need to point out a few characteristics. Your drawing has 4 boxes with arrows pointing inside. These are cameras. Okay, these show your elevations, front, back, right, left. Don't delete them. Okay, please don't delete them. You can rebuild them, but then it changes how everything's cross-linked in Revit. So everything you do is going to be cross-referenced with everything else that you do. And when you break a link, you have to go through and do a lot of fixing. It's not terrible, it's just time-consuming. Okay. All right, everybody ready? Everybody with me? Because we're only doing this once, and then you're on your own. So, are you with me? It's kind of nice. Okay, so we're gonna kind of walk through here a minute, bring it in, and then we're gonna let you we're gonna do a little play in Revit. We're gonna insert a CAD drawing. So across the top in the Insert tab, we're gonna import CAD. That's where you're gonna go. Kind of right underneath Mass and Site. So click on Import CAD, and you then get a window that comes up. Now, you got to know where you saved your AutoCAD file, right? So you can hit the down arrow and go back into where you're at. Got 2 documents now. Whoa, someone did some number on my computer. Yeah. So go down and find where you've stored your files. Select the house that you've done. And open, and just hit open. So once you find your file, just hit open. It's just gonna plop it down in there. Okay, which is fine. It's just not where we want it. Okay, it's just gonna plop it, and we got to now manipulate it. Okay, so I'll let y'all get that loaded in there. Is that opening up now? Thanks. Okay, we got, well, you think we got a lot of time, then all of a sudden it just disappears. Okay, if you'll now bring your cursor, you need to be, if you see it, it's probably not set for you to select anything. It's probably got a crosshair on it. So if that's the case, you always have this modify button. It never goes away. It's always in the same spot. It's the very first thing on every ribbon. Click on modify, and then come over and select your house. You'll see it's one big block. You pick any part of it, you get the whole thing, the big old square, right? Just click on it once. And you should see a thumbtack in the middle of it. You see that? Okay, that means it's pinned. And when it's pinned, it can't move. It's like locking a layer. Some of you played with that and found out how. So we need to unpin it. So just click on the pin. And if you see the point of the pin, it's unlocked. If you see the top of the pin, it's locked. So unlock it. Then use the move icon right here. And move in Revit is MV. MV for move. I don't know why, but they did MV. And when you get that, then you can just pick a point and you're going to drag inside those cameras. You want to drag your whole thing inside the cameras. Okay, now this is still 2D. It is not 3D. Okay. Once you get it positioned, go ahead and pin it again. And go back into the Insert tab. Make sure we're all good there. Yep, and we're good. Now, once you get that in place, we're going to save this because I need to teach you Revit now. We got our house put in there. We're going to do a save. So you're going to do File, Save As, Project. Make sure you Project. File, Save As, Project. Who's still pinning and moving? Okay, I'll wait just a minute. Is that opening up for you, Joey? That one's not opening up either. Taking a while.
I got it.
You got it? Okay. But we'll get you caught up before it's over. When we go. All right, we're going to save it as a project. You're going to put it into where you want it. Now, you can give it a new name. If you don't like the name you had before, give it a name you like. Oh, I don't know. What am I thinking? What's a good? Corona 1000. Call it Corona 1000. Seems like a good name. We might as well go with the flow, right? Why fight it? It's gonna get us all. So we give it a name and then hit save. Okay. And that's what I want you to hold. So I really don't want you doing a lot with this over the weekend. You've got stuff to do. But if you want to, I want to get you where you can play with Revit a little bit to get a little bit more familiar with it. Okay. So once you get that saved, to close your file, you just click on the X's of the tabs above. So both of these tabs are the same file. So when you get it saved, just close out one, close out two, and it's done.